The countdown had reached T-4 minutes when she said it. Not into the radio, not through the intercom, not in the careful language of official protocol that had governed every word spoken in that control room for the past 11 hours. She said it across the room, in a voice that was not loud, but carried the specific quality of certainty that makes large spaces go still. 3 words. The launch director looked up from his console. The flight operations chief turned from his screen. 41 engineers and technicians in the Meridian Aerospace control room at Cape Canaveral stopped what they were doing and looked at Imani Cole, who was 29 years old, who had been awake for 19 hours, and who had just said the 3 words that no one says 4 minutes before a $900 million satellite launch, unless they are completely, irreversibly certain. The director of launch operations, a man named Garrett Foss, who had overseen 47 launches in 22 years, and who had, at various points in the past 6 months, questioned whether Imani Cole had the seniority, the experience, and the institutional standing to be in that room at all, picked up the hold phone. He looked at it. He looked at her. And then he did the thing that would save the mission, the satellite. And $900 million of public and private capital. He listened. 4 years before T-4 minutes, Imani Cole drove to her first day at Meridian Aerospace in a 2009 Honda Civic with a cracked dashboard and a mechanical engineering degree from Howard University that her department chair had described at graduation as representing the strongest undergraduate thesis the program had produced in a decade. She was 25 years old. She had grown up in Baltimore, the daughter of a high school physics teacher who spent his evenings working through textbooks with her at the kitchen table, not because she struggled, but because neither of them wanted to stop. She had gone to Howard on a merit scholarship, worked 2 part-time jobs throughout, graduated summa cum laude, and received 3 job offers in the final semester of her senior year. She chose Meridian because Meridian was building things that went to space, and she had wanted, since she was 9 years old and her father showed her a library book about the Voyager program, to be part of something that left the atmosphere. Her first year at Meridian was a precise and instructive education in the distance between the thing you want to be part of and the position you are initially assigned to within it. She was placed in the Structural Analysis Division, entry level, which was correct for her seniority, and which involved, in practice, running verification checks on calculations that senior engineers had already made, and that were, in the vast majority of cases, already correct. It was not glamorous work. It was the work that needed to be done by someone who understood what they were looking at, and she understood what she was looking at. And she did it with a thoroughness that her immediate supervisor, a man named Phil Decker, noted in her first performance review as exceeding expectations for the role while observing, in the same review, that she should work on deferring more readily to senior team members on questions of interpretation. She read that line 3 times. She did not argue with it in the review meeting. She did not argue with it afterward, to Phil or to anyone else in the division. She filed it in the specific internal record that professional women in technical fields maintain, because the maintenance of that record is a prerequisite for navigating what comes next. Then, she went back to her desk and continued doing the work the way she had always done the work, which was completely, without shortcuts, and with the attention to detail that her father had modeled at the kitchen table in Baltimore for as long as she could remember. What she had, beyond the degree and the work ethic and the capacity for detail, was something harder to name and more important than any of those things. She had the ability to hold an entire system in her mind simultaneously. Not just the component she was analyzing, not just the subsystem it belonged to, but the full architecture of interactions, how a stress load in one structural element would propagate across 3 others, how a thermal variation at the margin of the tolerance band would compound over a mission duration, how the thing would actually behave rather than how the model predicted it would behave. Her professor at Howard had called it systems intuition and had told her it was not teachable, that he had met perhaps 4 students in 30 years of teaching who possessed it to the degree she did, and that the professional environment she entered would either recognize it or waste it, and that which of those things happened would depend partly on the environment and partly on her. She had been at Meridian for 14 months when she identified the first anomaly. The satellite designated MX-7 was Meridian's flagship mission of the decade. It was a communications and Earth observation platform whose development had taken 6 years and whose launch contract with the federal government was worth, in total over the mission lifetime, something north of $900 million. It was the project that Meridian's entire engineering division had been organized around for the better part of 3 years, and its launch window, fixed by orbital mechanics and the specific geometry of its target orbit, was 11 months away when Imani was transferred to the MX-7 structural team. The transfer was not a promotion in the formal sense. It was a reassignment that Phil Decker had recommended, with visible ambivalence, after 18 months of Imani's verification work, returning results that were consistently more thorough than the analyses she was verifying. The MX-7 structural team needed someone to run thermal structural coupling checks on the main payload bus, which was the kind of work that fell between disciplines in the way that critical work sometimes does. Too structural for the thermal engineers to own, too thermal for the structural engineers to prioritize. Imani took it. She did not ask what it would do for her career trajectory. She asked for the full documentation history and started reading. She read for 3 weeks, not just the current design documents, the full history, the design reviews, the revision logs, the meeting minutes where decisions had been made and then revisited, and then made again differently. She built a picture in her mind of how the MX-7 had arrived at its current design, which decision had preceded which other decision, which assumptions had been made early and then carried forward without being re-examined. This was how she always started with a new system. Her father had taught her, over years of kitchen table physics, that you could not understand where something was without knowing how it had gotten there. The anomaly was in the thermal structural coupling at the main deployment hinge, the mechanism that would unfold the satellite's primary solar array 6 hours after launch. The hinge was designed to operate across a specific temperature range. The thermal model predicted that during the orbital insertion burn, a localized heat flux from the propulsion system would bring the hinge to a temperature 63 degrees above the nominal operating upper bound. This was documented. It was in the thermal analysis report from 2 years prior. The thermal engineers had flagged it, the structural engineers had reviewed it, and the conclusion in the meeting minutes was that the excursion was transient, less than 40 seconds, and that the hinge material's thermal mass was sufficient to absorb it without functional degradation. Imani ran the coupling analysis. She ran it 3 times, using 2 different methods, checking her work against the original model and then against her own reconstruction of the original model from first principles. She got a different answer, not dramatically different, the kind of difference that looks small in a table of numbers and is enormous in the physical world. The difference was this: the original analysis had modeled the thermal mass of the hinge in isolation. It had not modeled the thermal interaction between the hinge housing and the adjacent structural bracket, which was made of a different alloy with a different coefficient of thermal expansion. At the temperature excursion, the differential expansion between the 2 materials would introduce a stress concentration at the hinge pivot that the structural model had not accounted for. The stress concentration was transient. It was also over 40 seconds at that temperature, sufficient to initiate microfracturing in the hinge mechanism that would not be visible in pre-launch inspection and would propagate to full failure approximately 72 to 96 hours into the mission. She sat with this for 2 days before she said anything. Not because she doubted the math, because she understood what she was about to say, and to whom, and what the institutional weight of a 26-year-old engineer disagreeing with a 2-year-old analysis that had been reviewed and approved by people with considerably more seniority was likely to feel like in a room full of people who had spent 6 years building this satellite. On the 3rd day, she went to Phil Decker. Phil Decker had been at Meridian for 16 years. He was a good engineer in the specific way that most engineers are good, competent, experienced, reliable within established frameworks, and genuinely uncomfortable outside them. He listened to Amani's presentation, which she had prepared with the care of someone who understood that the first hearing was the most important one. She had the calculations. She had the comparison to the original model. She had a clear 1-page summary of the discrepancy and its projected consequences. She gave him 22 minutes. He told her the original analysis had been reviewed by the thermal and structural leads. He told her the thermal excursion had been assessed and cleared. He told her she might want to check whether her coupling model was accounting for the passive thermal control coating on the hinge housing, which he said could affect the heat transfer calculation. She told him she had accounted for it and showed him where. He looked at it for a moment. Then he told her he would flag it for the thermal lead to review. The thermal lead reviewed it in a 20-minute meeting 10 days later and concluded that the original analysis was sound. He said Amani's coupling model was technically valid, but that it was using a conservative material assumption for the hinge alloy that over-predicted the thermal sensitivity. He showed her the material specification document. She said the specification document was based on bulk material testing and that the hinge mechanism, due to its geometry, had a surface area to volume ratio that would make its actual thermal response meaningfully different from the bulk specimen. He said he had consulted the material supplier and was comfortable with the original assumption. He noted it in the meeting record and closed the item. Amani went back to her desk. She sat for a long time. Then she opened a new document and started writing. She wrote for 6 weeks, in the hours before and after her official work, in the particular focused way she brought to things she needed to get completely right. What she was writing was not a complaint or an escalation. It was a technical paper, a full peer-review quality analysis of the thermal structural coupling failure mode, with every assumption documented, every calculation traceable, every material property cited to primary source literature rather than supplier specification sheets. She pulled journal papers on hinge mechanism failures in analogous thermal environments. She found 3 historical cases in the public literature, 2 from academic publications, 1 from a declassified NASA failure analysis, where the specific mechanism she was describing had occurred. She built the case not as an argument, but as a document, the kind of document that exists independent of who wrote it, that stands or falls on whether the physics is correct rather than on the seniority of the person presenting it. She sent it to Phil Decker with a cover note that said she wanted to make sure the analysis was fully available to the mission team before the final design review, which was 8 weeks away, and that she was happy to discuss it with anyone who had technical questions. Phil Decker read it. He forwarded it to the MX-7 chief engineer, a man named Douglas Reyes, with a note that described Amani as a junior analyst who had developed a concern about the hinge analysis and had produced this supporting document, and that he wanted Douglas to be aware of it. Douglas Reyes read it in 2 days and called Amani into his office. He asked her 3 technical questions. She answered them. He asked her how long she'd been at Meridian. She told him. He looked at the document again. He said he was going to have the chief thermal engineer and the chief structural engineer review it independently. He said he was not committing to any outcome. He said she had done the right thing by writing it down. The independent reviews took 4 weeks. They came back split. The chief structural engineer found the analysis credible and the failure mode plausible. The chief thermal engineer held to the original assessment. Douglas Reyes sat in a room with both of them and with the document for 3 hours and made a decision that would define the rest of his career in ways he did not yet know. He said he was not comfortable proceeding with the launch design without a physical test of the hinge mechanism under the thermal excursion conditions. He authorized the test. He noted in the decision record that the test had been prompted by analysis submitted by Imani Cole. The test took 6 weeks to set up and run. The hinge failed at 81 seconds into the thermal excursion. Not catastrophically, it did not shatter or seize, but the microfracturing that Imani's model had predicted was visible in the post-test microscopy, progressive and exactly where she'd said it would be. The design team spent 4 months on the redesign. The launch was delayed by 6 months. The cost of the delay was significant. The cost of deploying a satellite with a hinge that would fail 72 hours into the mission, a satellite that, after deployment, was not retrievable and not repairable, was $900 million and a federal contract and the company's reputation in the market that mattered most to it. Imani was transferred to the MX-7 lead structural team. She did not receive a formal apology. She received, instead, the specific institutional acknowledgement that comes when an organization quietly reorganizes itself around a person it previously underestimated. More access, more responsibility, more of the decisions that needed to be made correctly. She took all of it. She did not make anyone perform the acknowledgement they owed her. She had what she'd always wanted, which was to be in the room where the work was done correctly. And the work was what she was there for. The launch, when it finally came, was 11 months after the test and the redesign. The hinge had been rebuilt with a single alloy housing that eliminated the differential expansion problem entirely. The thermal model had been revised. The coupling analysis was now standard procedure for all hinge mechanisms in the Meridian design process, and the 3-page technical protocol that codified that procedure had been written by Imani Cole and carried her name in the document header. She was on the launch team. Not in an observational capacity, as a primary analyst, one of 41 people in the control room at Cape Canaveral who were responsible for the mission's success. She had been awake for 19 hours when the countdown reached T-4 minutes. Because she had been awake since the beginning, because she did not know how to approach something this important any other way. What she saw at T-4 minutes was a telemetry reading on her secondary thermal monitor that did not match the predicted profile by a margin that was, in the absolute sense, small, in the context of what she knew about this system, about how it had been built, about where its sensitivities were, about the specific relationship between thermal profile and the behavior of the redesigned hinge housing. It was not small. It was the specific kind of deviation that precedes something. She had spent 4 years learning what precedes something looks like. She ran the check once in her head. She ran it again. She had 18 seconds. She said 3 words across the room in a voice that was not loud, but that carried. Hold the launch. Garrett Foss, the launch director, looked up. He looked at her. Every person in the room looked at her. She held his gaze and did not look away, and did not elaborate, because there was no time to elaborate, and because she had learned over 4 years that the elaboration comes after. He picked up the hold phone. He called the hold. The countdown stopped at T-3 minutes 41 seconds. She had 50 seconds to explain before the hold protocol required a formal technical justification submitted to the range. She used 43 of them. She showed Foss the telemetry, the deviation, the model prediction, the gap. She told him what the gap indicated about the thermal state of the hinge housing and what the thermal state of the hinge housing indicated about the redesign's performance under the actual pre-launch conditions, which differed from the modeled conditions by a factor that the model had not been updated to reflect after a last-minute change to the Launchpad Environmental Conditioning System 3 weeks prior. Foss looked at the screen. He looked at the number. He looked at her. She said, "It needs 4 hours." He held the launch for 4 hours. The environmental conditioning was recalibrated. The thermal profile normalized. The telemetry came back within the predicted range. The countdown resumed. At T-0, the rocket lifted, and the $900 million satellite rose through the atmosphere and deployed its solar array at 6 hours and 4 minutes mission elapsed time. The hinge opening cleanly, exactly as designed. In the debrief the following morning, Garrett Foss went through the hold in the precise technical language of post-launch review, tracing the telemetry deviation, the analysis, the recalibration, the outcome. At the end of the section, he said something that was not in the standard debrief template, and that the people in the room would discuss for years afterward. He said that in 22 years and 48 launches, he had held a launch twice on the judgment of a single analyst with a single telemetry flag and no time for committee review. He said both times, the analyst had been right. He said the question that kept him up some nights was not what would have happened if he had listened. It was what would have happened if he hadn't. Imani was sitting in the third row of the debrief room. She was still wearing the same clothes she'd worn in the control room. She had slept 3 hours. She wrote down what Foss said not because she needed it, but because her father had taught her to write down the things that were worth remembering. And this was worth remembering. And she intended to tell him about it on the phone that evening, from the parking lot of whatever coffee shop she found near the hotel. In the particular late evening way they had always talked about physics, and what it cost and what it gave back. She had been 25 when she drove to Meridian in the 2009 Civic with the cracked dashboard. She was 29 now. The Civic had been replaced by something with working air conditioning and a dashboard that was entirely intact, which she regarded as a form of progress sufficient to itself. She had a thermal structural coupling protocol in the Meridian design standards that carried her name. She had a hinge housing orbiting the Earth at 7 kilometers per second, doing what it was supposed to do, because she had paid attention and said what she knew, and held to it when the room pushed back. She had not done it for the recognition. She had done it because the physics was the physics, and the satellite was real, and the $900 million was real, and the failure was preventable, and she was the person who could see it. That was the complete answer. It had always been the complete answer. From the kitchen table in Baltimore to the control room at Cape Canaveral, you do the work because the work is real. And you say what you know because what you know is true, and you hold to it because the alternative is not an option you have ever been willing to live with. Her father picked up on the second ring. She said, "We launched." He already knew. He had been watching the feed on his phone since T-2 hours, the way he had watched every milestone in her career. From the parking lot of the high school where he still taught physics to students he still stayed late for. The ones who didn't want to stop. He said, "Tell me everything." She started from the beginning, the way they always did.